And in this video we are going to discuss a sorting technique, heap sort. How to sort the elements using heap sort technique with the problem we discussed in previous videos. Now we are going to implement heap sort technique. Okay, so I am writing comment section. Program to implement heap sort. So include the header file #include stdio.h. Now, so in main function void main, or you can write int main. First declare the variables. We have to read an array, that's why I is required. Array size n and array elements. Now first read array size. Printf, enter array size, then scanf %d address of array size. Now after that we had to read elements into the array. Enter elements into the array. Use loop to read the elements. Try equal to 0, I less than n, I plus plus, scanf %d address of I. Reading elements into the array. After reading, we have to sort. That sort we will do in this method, heap sort method. The parameters are, one is array and another one is array size. So all sorting will be done here. Now we will print the sorted array. Printf, the sorted array is semicolon. Printing the array loop is required. I equal to 0, I less than n, I plus plus, then printf %d, give some space, comma, of I, put semicolon, return 0, successful execution. So save this program. Heap sort.c. Okay, now coming to heap sort program. Heap sort function, not a program. Heap sort is the function name we have considered. Now we will write a heap sort method. So it returns nothing. So void heap sort of, it is taking two parameters. One is array and another one is array size. Okay. Now, so first in which position we have to verify the heap sort technique. First we will check n by 2 minus 1 position. If you are starting array from first position, then check heap max heap property at n by 2 position. Now we are starting from 0th position, that's why we had to check at n by 2 minus 1 position. Okay. So now I am declaring loop control variable is required na. So I variable. So in which position we have to verify? N by 2 minus 1 position. Up to which position we have to go? Up to root node, which is nothing but 0th position. Every time what we have to do? We have to decrement I. So first at n by 2 position, means n by 2 minus 1 position, we are checking the heap property, max heap property. So if it is not satisfying, then what we are doing? We are modifying or we are converting that into a tree which satisfies max heap property. That means parent is greater than its children. All that we will do in one method. That method is heapify method. Heapify of a comma n comma In which position you want to verify? In ith position. So that is I. Okay. What is going to happen here? Here, first, for the given complete binary tree, max heap will be constructed. So I'm writing a simple point here, construction of max heap. After constructing max heap, what we are doing? We are swapping the first position element and last position element. Okay. So for that purpose, swap first and last elements and repeat. That means loop is required. So for I equal to n minus 1. Why? Because first position element and last position element we have to swap now. So that's why. Okay. So for I equal to n minus 1, which is last position. So that you have to do up to 0. If it is equal to 0, only one element, no need to swap. So that's why I greater than 0 and I minus minus. So we have to swap that last position and first position. Okay. So to sort the first element and to swap interchange, to swap first element and last element, we have to call the method swap method. Why? Because we are not doing here. We will do that swap process in another function. So call the method swap. Which elements we have to swap? First element. First element is nothing but of 0th position. And last element is nothing but ith position element. Okay. And here I am using call by reference. Why? Because if you have used without call by reference, if you have used call by value, the modifications will not reflect to heap sort method. So that's why. So that we are doing with call by reference. Okay. So now, after swapping first element and last element, if you are unable to understand this, you see the solid example. So which I have done in previous videos. You check that one. Okay. So after swapping first element and last element, it may not be a max heap. So that's why again we had to heapify the tree. So I'm calling again the method heapify. Heapify method. Heapify of A, which position? 9th position and 0th position. These elements we have to consider. These elements positions we have to consider. Okay. So now, so I think it is clear. So what we have done is, so we are swapping first element and the last element. After swapping, it may not satisfy max heap property. That's why we are interchanging those two elements, and then after interchanging, we have to reconstruct the tree into max heap. Now coming to this heapify method. Close this heap sort method. Now coming to this heapify method. If we have written heapify, then it is over. Your program is over. Okay. So this is a heapify method. Void heapify of how many parameters it is taking? 3 parameters. Okay. One is an array variable, and another one is up to that how many elements are there, that is stored in I. That's why that we are considering as n. And in which position we have to verify the max heap property? Ith position. Okay. So those are the parameters. What is this heapify? Heapify is changing your normal complete binary tree into max heap. Okay. So how can we construct a max heap? We have to check each and every node whether that node is greater than its children or not. Children is nothing but left child, right child. So we have to initialize left child and right child. Okay. So integer, I'm writing left child and right child, and we don't know which one is the big child. I'm taking these three variables and initialize that. Okay, as we don't know which one is a big child, so we are assuming, so first we are taking this root node in big child position, and its left is 2i plus 1 and its right is 2i plus 2. Okay, so initialize big child equal to I, left child equal to 2i plus 1 is the left child position. So 2 into I plus 1 is a left child position. Then right child position is 2 into I plus 2. It's a left child and a right child. Now we have to find out in between left child and right child which one is bigger. That we have to find out now. So check the condition. If, and that must be if, we have to check whether right child is there or not. If right child is not there, left child will become the big child. So that's why we are checking that one. So if left is less than n and your left child is greater than, already we have assumed this is the largest element in a big child. Not here assumed, we have to compare with its parent, na? So that we are comparing. Okay, A of left is greater than A of big child. Okay, then which one is the largest element? The largest element is left child. Okay, similarly check for right. So if right is less than n and A of right is greater than A of big child, then which one is largest element? Right child is the largest element. Okay, so now save that. Now we have to check whether that largest element is the position, is it equal to I or not. We have to check. Okay, check that. If largest, if it is not equal to I, then we have to interchange call by reference. So call by reference means address we have to pass A of I comma address of A of big child. Here largest place we have taken big child, na? So that is a big child. So here it is that we have to interchange big child. Okay, now again the same process you have to repeat. So that's why we have to call recursively the method. I'm calling the method heapify of A comma n comma big child. Okay, so now what else we have to write? We have to write this swap method. So we will write a swap method here. So for see, I'm taking all these declarations to the beginning. Okay, so now interchange method I'm taking. So interchange method, swap method. So void swap of integer star, call by reference, so that's by pointers. Okay, integer temp equal to star x star x equal to star y, then star y equal to temp. Save it. I think we have written all the functions. Saved, compile and run. Yeah, here it is common. Yeah, right child it is. So here we will write the condition like this. This is one condition. And this is another condition. And finally we will close this. Yeah. Okay. Now execute. Yeah, here left is nothing but left child, na? Here also left. Here right means right child. Here left child, right child. Okay, compare child. Largest, it is not largest. Now what we have considered big child. Run the code. Now any parenthesis missing here? Yeah, semicolon we missed. By here also semicolon we missed. Check the answer. Enter array size of 5. Enter array elements. So it is not printing the sorted array. Let me check it. Why it is not displaying? Yeah, here. See, this one is. This we had to put in the brace now. After swap, again it has to check maxi property. Okay, so put in a block. Compile. Run the code. 5, 4, 3, 2, 1. Yeah, it is sorted out. Okay, so this is a heap sort program. Hope you understand, students. See, before going to implement this code, see the problem once you solve that example. Okay, after solving that example, then it is easy to understand the program. Okay, so if you understand this program, so please share with your friends so that they can learn. If you like the video, please share and subscribe the channel. Thank you, students. Have a great day. Bye.